Hey YouTube fam and pilots, if you like what you see on the channel, go ahead and click that like and subscribe button to get some more drone and game goodness. Thank you, and here's your video. Hey YouTube fam and pilots, this is Madman216 FPV. Welcome to the channel. If you want to go from this to this, then you've come to the right video. Stick around and I'll show you a thing or two.
Alright guys, so you want to build your first FPV drone. Well, this is the video that's going to help you with that. This is a build only video. This is not a Betaflight tutorial. Those are found elsewhere, which you should have no problems finding them. This is just going to go over the basics of the build, what you need for the build, and how to make it happen. And I'm going to assume that you guys already know how to solder, so we're just going to go right through it. Here we go.
Alright guys, I can't stress this anymore. You need to make sure you have an idea, a vision of how you want your build to go. Always plan first. You know, if you want it to be a 4S, a 6S, a cruiser, whatever, just have a vision of how you want the build to go. Always. Alright, so two of the most important rules of thumb that you want to take in is before you get into building, you want to make sure that you have the proper tools and the proper environment. Very important. One of the things I go by is I love to have my environment brightly lit.
What is divine light? Aziz, light! Much better, thank you, Aziz.
Seeing what you're soldering is very key, very important. To tell the difference between a code solder and a good solder is a lot visual. So definitely make sure you're brightly lit. Have the space to work. Another key thing, you don't want to be bumping elbows into anything while you're soldering. Make sure that you have a safe place to work, nice wide open space, and all your necessary tools. Alright guys, so we're going to go over a general parts list for a 5-inch analog drone. Of course, you want to start off with your frame. Definitely need a camera so you can see what's going on your goggles. The VTX board. Good flight controller. Main difference between your flight controller and your ESC is going to be a USB connection. The ESC, like I was talking about, of course, controls your motor outputs. Radio receiver. This example is a Crossfire Nano. Motors. I tend to add a little extra to my drones. This is going to be a locating beeper with LED lights. It acts as a beacon if you lose your drone and you're still powered. Set that to a switch to your on your remote. Antennas are very important, of course. This here is a VTX antenna. You want to make sure, as a rule of thumb, that your antennas polarity match from your VTX to your goggles. This example is a right-handed circular polarity. Receiver antenna. Also, this is going to be a Crossfire. And, of course, propellers. Make sure you match your propellers proportion to the size of your frame. This is a T-motor 4.9-inch propeller that goes with my other drone. But I mean, you have 5-inch, 7-inch, depending on the build. This example, of course, like I said, it's a 5-inch, so use the proper props. All right, guys, so now that we got the parts list out of the way, let's go ahead and get ready to do this build. All right, so there is another tool that I totally forgot to mention that you will definitely need in your builds, one that will help out tremendously. This is a rubber base Gorilla double-sided tape. This is a godsend for us FPV peeps and builders and pilots. I have both a black and a clear coat, or a clear colored. It does not matter as long as it gets the job done, your coloring. But yeah, you need this stuff. The cool thing about this is, since it is a rubber material, it does absorb shock. And it's very, very tacky, so it's going to keep those pieces on. I mean, you literally have to be hitting a brick wall or something at 100 miles an hour before that they pop off. But it's very, very, very recommended, highly recommended, and useful tool in your FPV arsenal. All right, so I went ahead and decided on using a different frame than I had in the example earlier on the parts list. This is an iFlight, a Sedora XL5, 5-inch Truex frame. And I am going to go with also a different set of motors that was previously listed in the example parts list. These are the Flash Hobby 1750 kV 6S King motors at a 2207.5 size, like the military gun drab green aesthetic for these motors. Yeah, so this is going to be a 6S 5-inch basic quad. One of the rules of thumb that you want to do is, when you're preparing to do your soldering, make sure you solder all your pads first. I start with the ESC, and I go ahead and I do all of my motor points pre-10 my battery leads as well. For the battery lead section, when I do install the battery lead, I'm going to go ahead and use a wide tip soldering iron. I suggest you guys do the same thing, because trying to heat these larger pads with a smaller or fine tip soldering iron is not going to cut it. You're going to run into a lot of problems. So just get like a wide blade, swap them out on your soldering iron, or just purchase a wide blade soldering iron just for the purpose of doing the XT60s. Alright, so I already had started with the pre-soldering of the pads on the ESC. So next up, we're going to go ahead and line up our motors and get the wiring ready for trim. I suggest to go ahead and pop in a couple of screws to hold your motor in place. Make sure it's not going to be able to shift, so you have an accurate idea of your motor placement as far as it comes to soldering your motors to the ESC. It's definitely important where your motors are stationary, so you don't cut your wires too short. Yep, that way your motors are nice and solid on the arm there, and you can start getting an idea of your wire length leading to your ESC. Also, you want to go ahead and, I use this as a rule of thumb, just try to line your respective wire with the respective pad on the ESC. Zip ties are going to be a very important tool for your build and any builds for this point on. I'm going to use this zip tie to make a temporary lockdown of the wiring so it's not flopping around, and you have a general, a better accurate cut on the length of your wires leading to the ESC. Yeah, this part doesn't have to be pretty. You just want to keep the wires really from separating themselves and flopping around all over the place. Just get the zip tie as far up on the arm as you can. And, you know, just keep in mind that this zip tie will be cut back off as your build goes along. This is just a temporary placeholder for these wires. See, now I don't have to worry about the wires coming, you know, pretty much away from each other there. And I can focus in on the length leading to the ESC. By the way, this is a 4-in-1 ESC, so these newer models, you don't have the separate ESC for each individual motor. These 4-in-1s make it a lot easier for these builds, a lot quicker as well. Alright guys, before we get into the meat and potatoes of this thing, I'd like to go ahead and give a shout out to FPV Lux, who in the mail today I got this no clean solder flux pen, and also this awesome Joshua Bardwell cinnamon roll whoop shirt. Looks pretty cool. Thanks a lot, guys. I'll leave a link in the description where you can join up. It's $20 a month for an awesome shirt and a piece of FPV swag. Alright guys, for this part of the assembly process, I'm doing my wiring to my ESC, and I'm going to go ahead and measure in a little bit of allowed slack. That way, if I have to move the ESC around for any reason while assembling or whatnot, I don't have to worry about my wires ripping or my pads coming off with my wiring. Right now we are on our last motor that has to be strung up or wired up to the ESC. I have my zip tie here to keep everything in place. Just remember, always leave yourself some slack when you're wiring up your motors to your ESC. Nice measured. About right there. Oh, that was interesting. My battery in my GoPro just died, so where were we? Alright, stringing this thing up here. Yeah, it just leaves slack. Okay. You don't want this thing to be guitar strings all the way across there. Yeah, because if a wire breaks or gets caught, you stand a chance of ripping your pad right off your ESC, your PCB board, and that is not a good thing. Not the easiest thing to fix. And with this less expensive Speedy B ESC, it's only padded on one side, so okay. Number 2. And I always get that middle wire a little shorter than I want. So, since I have longer thumbnails, I can basically just kind of strip these out pretty easy. You don't want to overdo it. That's a little tiny bit ought to do. Don't forget, when you're tinning your wires, you definitely want to pre-tin, by the way. Strip, fan, and twist. Keeps little fray wires from bridging, sticking out while you're tinning these. And you go ahead and strip, fan your wires, and twist. Let's get these tinned up so we can hook them up to the ESC. Tinning's pretty quick. Okay. Once again, tweezers, an essential tool, so you don't burn your tips of your fingers or your fingernails. One. Keep your solder point tinned. Also, make sure you're lining up your motor wires with the respective pads. I usually do that as a rule of thumb. This freaking middle wire, I always get that short. Yep, nice and clean. Make sure your solder covers the wire completely. Go over if you need to. And number 3. Nice. There you go. All of these are soldered in. Push on your wires, make sure none of them are going to pop off, and make sure they have some nice slack. Sweet. Alright, so next thing we're going to cover is those dreaded battery pads. The bigger battery pads. We're going to switch to my wide blade soldering iron to take care of these. And don't forget, since this is a 6S build, definitely do not forget to pop that capacitor on there. This lovely capacitor is already marked with the negative stripe on there. Here, let me go ahead and pull that bad boy out real quick. Negative and positive are important on this as well. And you gotta child-proof this stuff. Alright, so. Okay. With the capacitors, rule of thumb is usually your negative leg is going to be the shorter leg, just in case you get a capacitor that isn't really clearly marked like this one happens to be. This is one of the standard capacitors. The Japanese higher end capacitors happen to be fully capped. I will show you really quick here. Yeah, so these are fully capped over. They tend to be higher end, handle temperature a lot better. And on these, the little edge of that is your negative side. Of course, we're not going to fully use the entire length of the capacitor. Like I said, make sure that you planned your build out so you know exactly how much of the cap that you need to cut off. When I build these, I tend to stick the cap on top of the pads and solder them in after I have the XT60, the battery plug, soldered in already. A lot of these newer capacitor or newer ESCs have pre-drilled holes where you could just slide the cap in and solder it in place. I don't know, I'm just so used to just soldering the cap on top of the lines there. Okay, the XT60 battery plug that I'm going to use for this build, due to the fact that it's a 6S build, is going to have the thicker 12 gauge wire. Now that's a preference for me. You know, the higher voltage coming from the 6S batteries, I tend to go with the higher gauge wire. This is a 12 gauge on my 4S builds. Here's another XT60. This is a 14 gauge. You don't have to use the full length of the plug. It's pretty much coincides with your build. With mine, I'm going to cut about a quarter of it off, so the plug will just stick out of the back of the quad slightly. You know, I'll probably use a zip tie or a 3D print to lock it down. Alright, instead of using my little snips, I actually used my wire stripper. You're definitely going to have to use a wire stripper to strip some of these down as well, some of the length. Once again, don't go overboard as far as how much you're stripping. Just a nice little section will do. Contact is key. And be careful that you don't chop into any of the wire that you are stripping from there. There we go, a nice clean cut right there. It's nice and easy. Okay. Minimal to no wire loss is preferable. And once these things are stripped, don't forget to fan them out like so, and twist. It keeps what I call the little hairs from sticking out. Makes a good bead of solder. Fan out. And twist. So I have a wide blade soldering iron just for the purpose of getting the battery connector soldered onto the ESC. Believe me, it will save you loads of time. Rule of thumb, always use a wide blade on those connectors. Trust me, it will save you a headache. Alright, so I ended up taking a little bit too much strip off, so I had to cut the wires down a little bit there so they're a little more nubby now. And they'll go onto the pads nice and easy there. Alright. I am going to tin these really quick. Very, very important to at least tin these connections for sure. Pre-tin these. Very important. Okay. Turn that sideways like that. Okay. Pre-tin this blade. Got a nice bead of solder on this thing. There we go. Nice bead of solder. Trust me, this makes it a lot easier when you put these on, and then when you put that capacitor on as well. Don't be afraid to hit that up with a little bit of flux if you need to on the wiring itself. Oh, hit the camera there. All right. Okay, here comes the fun part. Let's adjust that. Right there. Red, positive, black, negative. Try to hit the pad and the wire pretty much simultaneously as much as possible. If you need to add more solder to the pad, that's fine. Ooh. Have to tolerate a little bit of pain, just a little bit. There we go. That's a good solid. Now it's okay if you have some of that solder sticking out the top there, because the next thing you're going to pop on there is your capacitor. This is the optimal place to stick your capacitor. This is where that filtration comes through at its most, right at that battery lead. Alright, let's see if I can get a nice little grip on that. Probably not. Alright. Look at your placement first before you solder it on. Make any adjustments you might need to make, and then go for the kill. Try to get that solder to cover the legs on that cap completely. You feel those legs sinking in, that's a good thing. Alright. And test for strength. Looks good. There you go. XT60 and capacitor. Mission accomplished. Take a little closer look there. Got your cap in place and your plugs in place. Out of all the things to have to solder on this drone, including the little pads on the flight controller, this XT60 is probably going to be your most challenging part if you are not properly equipped. Either wide blades for your soldering iron or get a separate wide blade soldering iron, a standalone wide blade soldering iron itself. And that's my regular. It's not really too much. I think this, it being a Weller, was 22 or 24, something like that. It's worth the extra effort. Makes that a no nightmare situation. Okay, so typical wiring between the flight controller and ESC, the communication cable, is a multicolored, double-headed cable such as this. Kind of looks like a ribbon, but it's not. It's wire. That goes between your multi-pin area here, and likewise on the ESC. Very similar to that. So if you have an already organized stack, same branded stack, then you really don't have to worry about the pinout arrangement. I mean, you can double check your diagram to make sure that everything matches up, but typically they sell them match up with no problem. You can just go ahead and plug and play from that point. But if you have, let's say for example, a like iFlight ESC and a T-motor flight controller, then yeah, you're going to have to look at both diagrams and look at your pinout arrangements between both the ESC and the flight controller.
Alright guys, I'm here back on my main computer with some diagrams opened. I mentioned earlier that if you chose different components as far as your ESC and your flight controller is concerned, pay attention to their separate wiring diagrams. It's very important. On this example, I have a Mamba F405 diagram, and this area here is your communications connection between the ESC and FC. And these pinouts are your ground, battery positive, and your motor connections here leading to the ESC. In this example, we have two separate iFlight ESCs here, and as you can see, if you match them, they do not match. Your two pins towards the bottom are reversed. You have your current pin here on this Mamba at the very, very bottom, and the current pin on this iFlight is next from the bottom. Now, if you go blindly and plug in your communication wire, you're going to fry something. More than likely, you're going to fry a good FC. So be careful and take care to look at your diagrams. What people do is they'll take whatever pin, either from the ESC or the FC, on that little wire that I showed you, and they'll swap the two. On one end, they'll just swap the two wires and plug them right back into the connecting head of that wire pack. Others will just go ahead and straight out solder between the ESC and the FC. Because if you flip a lot of these FCs over, they have actual solder pins. Like this Mamba flight controller has physical solder headers that you can solder wire straight to. The ESCs, same thing. They'll have their physical headers too. But whichever works easiest for you, I usually just go ahead and just switch the wire pins around and plug them right back into the wire head. But yeah, just keep an eye on that. Make sure you look over your documentation. Those of you who bought a matching stack, which is a matching FC and ESC, you really don't have to worry about it. It's pretty much just plug and play from that point. As you'll see in the rest of the build, just make sure you flip at least one twist on your communication cable between the FC and ESC. All right, on to the rest of the build.
All right, folks, that was the end of the fun part. This is where stuff starts getting a little complicated. So now we're going to go ahead and wire up this bad boy, your flight controller.